Hello, everyone. Happy Friday afternoon. So we will just my agenda item is not really a big number. It's just a few items I would like to talk about. So let me just tell you that in principle, your programming test number 4 would be very similar to programming test number 3. So I don't think the review session should be very long. I will definitely leave time for you to ask questions if you got any. So let me just go over 2 items I have in my agenda. I would just like to go over some reminders about what you should really get prepared for your upcoming programming test 4. And also there is one new bit that you will be tested, which is about static variables. And I will actually do some simple example together with you. So when you actually try the programming test number 4 practice test, you will be able to do it. Okay. So I think you should still really give yourself isolated and also give yourself maybe no more than 90 minutes or so to really finish the practice test that I made available to you, right? That's something you should do. And the workflow to follow will be exactly the same as how I advised you for the previous test. All right, so let me now talk about, so I think you can see my screen for sure. Let me now talk about quickly some reminders about the programming test 4, okay? So first of all, the coverage will be just the same as your programming test 3, which means it's mainly about OOP, right? So you should really know how to invert all the classes and methods from the JUnit test, and also how to define constructor, accessor, mutators, and also declare attributes. And you should also you can feel free to actually add in as many helper methods as you like, right? You got complete freedom to do it. And what's really important for the new coverage this time will be about static attributes, right? So if you recall from week number 10, I believe, for your lecture, we spoke about how you can use the static attributes, the static modifier, to actually to really do the automatic management of account IDs. So this will be the specific usage I would expect you to do specifically. Okay, that's something we'll talk about, right? That's my next agenda item. And there'll be no 2D arrays. However, for your lab number 8, which was just released earlier today, so that will require the use of 2-dimensional array. So you just need a little bit more practice. So I think we will only test you about 2-dimensional array in your written test and also in your exam. That's what we will do. But for your upcoming programming test 4, there will be no 2-dimensional arrays, right? We already specify that clearly in the guide. So what about the formats? The format will just be the same as your programming test 3. So you will be given just a JUnit test, and then you'll figure out exactly what to put inside the model package, right? So the same format. So I don't need to waste your time explaining that. And in case you're worried, there'll be no Android Studio mobile computing stuff, right? There'll be no. Okay? You don't have to worry about. We only do Android app. It's like it's a useful application for OOP only for your final 2 labs, lab number 7, lab number 8. Outside those 2 labs, we don't really do any Android stuff. Okay, what can you expect for programming test number 4? It will be harder than your actual programming test number 3. Let me just explain specifically about in what aspect it will be harder. In 2 aspects. Number 1, you will have to create more classes in the model package, right? So strictly larger than 2. But remember, in your actual programming test number 3, you are only asked to do, for example, let's say for one of the versions, it's about warehouse and also equipments. So only 2 classes. But for your programming test number 4, you can expect to deal with at least 3 classes that you have to build. Of course, I'll balance the amount of methods you have to build within the time limits, but that's something you should really expect to see. And then you will expect more methods navigating across classes. So something like this, right? Imagine that if you got some objects over here for one class, let me say class A. I'll just have some conceptual sketch for you. Okay, you can also see that in the practice test. So here you got A. For example, you got some array, okay, array attributes over here, and then the array attributes is actually is actually storing an array of other objects. Let's say each one of the objects is of type, let's say maybe B over here. Okay, let's say they also got some array over here, and they also point to another array. So you can see we got 2 levels over here. this should not be too surprising because you have seen that already in your lab number 6. So I think redoing your lab number 6, if you have time, will be a very ideal preparation as well. Okay, and then maybe each one of them is going to just point to another object over here, C. So you can see we can easily have 3 classes, A, B, and C. So this will be a very some kind of object structure you can expect in the actual test, right? Something like that. Not exactly the same, but something like that. All right. So for example, it could be that, let's say we got some object A. Let me use a different one. Let's say OBJ over here, objects. So here will be C. So if you say objects dot some method, let me say M, and then you pass some arguments over here. So this method here conceptually may have to somehow go over this particular array, and then when you actually look at some particular object stored in the array, they may have to go even further into this particular array over here, and then maybe try to look at the object at the bottom level over here. So that's what I meant by navigating across classes, right? So that's something you can expect to see in your actual test. But I think redoing your lab number 6 to really understand and to visualize what's really happening there. And also, I believe the methods in your practice programming test 4 also have methods like that. If you practice them, you should be all right. All right. Okay, so for the practice, what you should do will be lab number 6. That'll be very important. And also, you got 2 practice tests available to you as well. I don't think you should really need to redo lab number 5. I don't think that one will be so necessary. That one is really just about setting the status message. I think that could be useful, right? Apart from that, I think lab number 5, somehow you're only dealing with just one class. So I think you want to get more used to about dealing with multiple classes. So these 3 tests over here for practice will be more beneficial for you. All right. Do you have any general question about your programming test number 4? I can answer now before I move on to the next item.
Professor.
Michael.
Yes, I have a question about the practice test. I just finished it this morning, and I was wondering, is it all right that the static variable accumulates across tests? Or is that something that we need to consider?
Michael, good question. I think you're right. So yes, because the static variable is actually shared by all the instances of a particular, okay, I think what you're saying is this. Let me just draw that a little bit conceptual sketch for everybody. But I think the short answer is you don't really have to worry about the static variable being accumulated between the JUnit test methods. You don't have to worry. So when we test your code, we'll try to be careful when we create the instances. So let's say, for example, let's say if we have a class over here, class A, and then let's not worry about public, okay? Of course, it should be public, but let's just omit the modifier. And then let's say we got maybe some static integer and then I. For example, let's say initially it would just be let's say 1 over here. Let's say this is one of the classes you declare and also define in the model package. Okay, and then we also got your JUnit test. Okay, let's say you got your JUnit class, and then you have maybe the first one, let's say public void, and then test1. And then over here, let's say here, if we got, for example, let's say A, object number 1 is new, and then A over here, and whatever it is. And then you got another one over here, and also void, test number 2. Let me just use 2, so at least 1, so multiple. And here we got another object A, and also let's say called O1, and then new A. Okay, one thing to note, even though these 2 objects are simply called O1, but there's no clash over here because O1 over here has its scope within this particular test, and O1 here has its scope within this particular test, so there's no clash. However, let's say there's something I will show to you in my second item in the agenda. I will show that to you. Let's say this. Let's say we want to implement the constructor for A in such a way that, let me put it here. Let's say A will be the constructor over here. Okay, so let's say here, let's say we're simply just going to, let's say, somehow increments the value of I every time you try to create a new objects. So that means when you actually create this particular, and typically the JUnit test is going to run your test, all the test method in a particular order. Typically they try to sort maybe according to the alphabets, and then they will simply run one by one. Let's say we try to run this one first, and then what's going to happen is when you first create this particular object over here, so now at this point a.I will just be equal to 1 because it is how it is initialized to be. And then when you actually try to create a second object over here, even though it's apparently it's a different objects, but remember a static variable is beyond the level of individual objects. So here you will actually see that a.I is actually 2, right? So this is kind of like a subtle consideration that we will take when we test your code. But when you actually define your class with static variables, you don't have to worry. So Michael, does it kind of answer your question?
Yes, thank you.
Okay, good. I think it's a nice thing to point out, right? Okay, so it does cumulates, right? So between this particular method to this method here, let me just make it more explicit. That might be something that's useful for you later on when you want to dig in deeper into the JUnit test, right? When you beyond this course. So when you between the test method, between test methods, static variable accumulates. Okay, so that's the main point. Okay, that's something I can also show to you actually in just a moment. I will show that to you when I do the second item. Okay. Yeah, that's correct. So the reason that it will actually accumulate between these two methods, you can thinking this way. You can think about the JUnit test. It's just informal intuition. Think about your JUnit test is basically a big main program where each test method is a helper method that will be actually executed in sequence. So that's why the static variable that's actually beyond individual object will still be accumulated between the helper methods. Okay. All right. All right. Any more questions regarding the administrative issue aspects for the programming test? Anything you have doubts before I showed you how to use static variable? Any questions?
I do have another question.
Yeah.
But I'll wait until someone else asks their first, maybe.
Michael, you can go ahead. That's fine.
Okay, I'm just wondering if the size of this test will be similar to test 3, or will it be a bit beefier?
You mean the actual test?
Yes, like how many distinct
okay.
tests?
I think in terms of the number of test cases you will be given for your actual programming test 4, it will be more or less similar to programming test 3. It might be slightly more, but it wouldn't be many more. It might be slightly more.
Okay.
But I will still, I tell you what my consideration is. My main consideration, I haven't really designed my test just yet. I want to define it from scratch according to according to the dynamics for the class. So this is my consideration. Number one, of course, you got less than 2 hours, right? Of course, we got to take into consideration the time you need to download the submission. Download the projects, export the project, etc. So I would say strictly less than 2 hours for sure. I will consider that. Number two, so far we are actually now in. So I think that we started to learn about OOP since the first week after the reading week, right? So I think up to now we learned about 5 weeks of OOP. So we learned about, for example, we got 2 labs. And also we got the tutorial videos, let's say 6, 2, and also 8, right? And also we got also the practice tests as well, right? So that means our expectation on you compared with programming test 3 might be slightly higher, just when you're progressing for your grasp for OOP. But it will still be, I think it will still be reasonable, right? As long as you do the practice test, especially lab 6 and also 3 and 4, and then make sure you can really get yourself familiar with the pattern that we spoke about. Have the array of objects and also the integer counter, and also using loops to actually manipulate the objects. That's something we have spoken about many times so far. So I think as long as you can do that, you should be all right for the actual test. So Michael, makes sense to you?
Yes, it does. Thank you.
All right, very good. So guys, any more questions before I move on to the final item on my agenda? Yeah, so today's session is not really meant to be long. I think I just want to clarify some doubts if you have any, and also just to make sure you're okay with a static variable, because that's the only thing that's new that you have to study for this programming test. All right.
Oh, sorry.
Professor?
Yeah. Oh, sorry, go ahead.
Can you tell us the many different types of applications of we could use for the static variable?
Sorry, can I tell you the different? Can you say that again? I don't quite catch you.
I said, can you tell us the many different types of applications we can do with the static variable?
Okay. I think the main use, the principal use for static variables. Okay, let's say this. Why would you declare? So the question was, can I actually give you more example application for static variables? I think I can try to give you maybe another example maybe on Monday, so I can get a little bit more prepared. But for now, I can at least tell you what will be the principle for you to design your variables. Okay. So I think there's something also maybe I mentioned in the lecture as well, so you should check it out as well. So why would you actually do a non-static attributes versus also versus static attributes? So I would just summarize very quickly. You should really find a detailed list of differences in your lecture. I believe it's lecture week 10. Okay, check it out. So the main principle to learn about to know about non-static is really local to individual objects. Specifically, non-accumulative. Non-accumulative between objects, meaning that for one object to actually for one object to really updates their own non-static attributes is not going to affect the non-static attribute for another object, right? They are not going to influence each other. On the other hand, when we talk about static attributes, so they are kind of global amount the objects. Okay, and then symmetrically they will be accumulative. Amount objects. Meaning that if if object number 1 actually try to change the value for the static variable, object number 2 will be impacted, right? So that's really the key. And I think a very common usage for static variable is really to have a global ID, which we show in the lecture. I can try to find another maybe a slightly different way of using the static variables, but I think the principle is really the same. If you want to have something that's global amount all the objects, that's where you should really use static. So I think for all the application you will see, it should have that kind of flavor at least. Okay, makes sense to you?
Yeah, it makes sense.
Okay.
Thank you.
Yeah, you can. You know what? You can try to ask me again, maybe on Monday during the Q&A. I'll try to think about maybe another application, maybe briefly over the weekend. You can ask me again. Okay.
Okay.
All right. All right. Anything else?
Professor,
Mm-hmm.
may I ask one more question?
Go ahead.
I was just wondering because you said that we should put emphasis on doing the practice test again, and the lab for lab 6 is relevant. But I'm just wondering, are you then saying that we should not focus on the OOP for lab 7? Because I thought it was quite interesting too. Or
oh, you for lab number 7? Yeah. You know what? The reason I didn't quite mention, you know what? Actually, it's a good, yeah. The reason I didn't quite mention lab number 7 was because if I mention that, some of your colleagues who might just get confused, oh, they might think, oh, are you going to test us about Android Studio as well, right? So let me say this. If you really want to also try lab number 7, so maybe I would say this: only the model part of lab number 7. If you really want to review, you can review that part. That's okay. Because just the model part for lab number 7 is really identical to how we did it for lab number 5 and lab number 6. So that's okay. But you definitely don't have to worry about how to attach the controller method to the GUI buttons or how to design a GUI layout. You don't have to worry that. Make sense to you?
Thank you. Yes.
All right. Okay. One question from Sam. I always get some assertion error. How to fix it? Yeah, I would say, yeah, well, basically for the programming test and also for your labs so far, right? When you are given a JUnit test, none of them actually will pass. So that's really your main job to begin with. None of the assertion will pass. So how can you pass them? So I would say, number one, you can look at the written notes that we spoke about how to at least make the assertion compile, right? You can really invert the classes and methods that are actually used in the JUnit test assertion, and then try to make them compile. Number one, you can refer to the written notes. Number two, to really get a green bar for each test, you will have to really you have to know you're going to study exactly what's being intended for the JUnit test, because usually we say, for example, after I initialize a person object with name, let's say Jackie, and then after that I say person object dot get name should be equal to Jackie. So what does that mean? So that means you have to implement your class in such a way that it's going to initialize the attribute for name to Jackie and then return that value back to the user, right? So I would say it's really about how doing exercises over and over, and we did provide you with the opportunity so far, about lab number 5, 6, 7, even 7 and 8. I would say even lab 8, we are really following the same pattern. And then anytime if your method's return value does not quite match the expected value in the assertion, so what you should do is you should use debugger. Debugger is always your best friend, right? If your professor or your TA are not around you, I think you should really rely on yourself and the debugger. So you should really place the breakpoints around the line for the assertion, and then launch the debugger, and then try to step into the method that's being tested and try to see what wrong value has been returned, and then hopefully from there you can work out exactly what's wrong. Of course, I think things will get better as you accumulate more and more experience. But before that, if you really got completely stuck on passing a particular test, I think the best way to do it is maybe just speak to me as early as possible. That's really what I recommend the most. Because if you come to me, I'll try to look at the debugger together with you, and then I will say, maybe this is what you want to do, give you some hints. So that's what I can advise. Of course, I'm afraid I cannot really answer too many of your questions during the test, of course. So please make sure you approach me as early as possible, right? All right, any more questions regarding the test before I do some static variable exercise together with you? All right, hearing none, you can definitely still ask me, no problem. Let me just move on to Eclipse quickly, right? Something light. And this, in some way, is more like doing an Eclipse exercise from one of the topics we did in week number 10 lectures, when we talk about how you can use the static keyword as the static variable to actually create global variables for account management, automatic management specifically. Okay, so I try to make it maybe similar to what the test format will be, only one test to pass, right? So guys, why don't you take just 1 minute, okay? There's only one test that we want to make sure it compiles, and we want to make it passed as well. Why don't you look at these over here? Okay, I'll give you 1 minute. Take a look, and then before I walk over the solution together with you. All right. I would say pay special attention to the parameters or arguments being taken by each individual method. I think that will be the key to solve this particular exercise. It's not exactly from practice test 4, but I think once you know how to do it, you will be able to solve the one in the practice test, right? That's why I want to do this specifically. I don't need to redo the entire practice test. It might be too boring for you. That's something you should really try to do it before Wednesday. Okay. So guys, take another 30 seconds to read over the test over here, and then we'll do it together. Okay, maybe a few more moments. All right, let's now try to do it. Okay, basically, you can see this part here is not compiling. We learned before very well, because we're using the student as a type for this particular variable. But it simply say if you move your mouse over, it tells you that student cannot be resolved to be a type. So what can you do? Create that type, right? So what I would do is we're going to follow exactly the same formats. So I'm going to create a new class over here called students. Okay, because they are in different packages, so please make sure it's public, right? You want to make sure. So the principle will be all the attributes should be declared as private, and all the methods that are actually inferred from the GUnit test, because they are called in a different package, they should be declared as public. Any helper methods you actually create for your coding, it will be up to you whether you want them to be public or private. I'll leave that freedom to you. Okay. All right. At least when we go back here, you can see. Let's see this. Oh, another thing to do. I forgot to add one line over here to say where to really use the student class. I can say import model. So I'm importing all the classes from the model package, but you don't have to worry. This line will be given to you in the actual test, so you don't need to write it out yourself. Okay. So now you can see at least we got rid of the errors from the left-hand side over here. It's gone. But now the problem is, as is right now, we only got an implicit default constructor for the student, taking no parameters. However, from the GUnit test, it's requiring a version of the constructor with a string. It looks like a name, right? So why don't we do that, right? So we should really create a new constructor version, like a constructor in the student class, right? Let me go back here. Okay, and it should be public always. Okay, and then rather than Alan is just one example. So it should be string. Maybe I'll say name over here. All right, that's what I should do. Okay, just for now, at least to make things compile. And then let me go back. You can see now everything compiles up to here. And then we are now facing this compilation error. And let me just remind you very quickly, if you want to see the detailed derivation process, you can refer to the written notes, or maybe refer to the review session 2 weeks ago, where we spoke about how you can make things compile for your practice programming test number 3, right? You can refer to that video. But very quickly, you can see the get name. Apparently, it should be an accessor because you're using the return value from this particular method call to be compared against Alan, which is a string. So you can see that the return value should be of type string from get name. But the remaining question is, where should we put this method into, right? So you can see Alan is a context object. Alan was declared to be of type students. So that means get name should be declared in that student class returning string, right? So that's the reasoning process. Let me do that. So here, the method should be public returning a string and also get name. And should be no parameters over there, right? And then since it's a reference type, we're just going to return some default value for reference type. We'll work out exactly what to return later. So it's going to be return null over here. All right. As I go back here, so you can see everything up to now has compiled. Okay. Seems to be one more, right? You can see similar idea. We're still calling the same method. We're still calling a method from the same context object. So we should still introduce this method into the student class. Okay, and then it seems like it should also return a string value, right? You can see Alan-3 is actually a string value, right? So we should do something similar, get ID, right? Let me copy the name. So what I should do here is I should say public string get ID, okay, taking no parameter, and then let me just say return null for now. All right, let me go back here. You can see everything compiled, and of course, if I try to run this JUnit test, I should get a red bar, which is not surprising because I haven't done anything yet to all the empty methods. That's what we should do. Okay, let's now do one by one. So this part over here is a very standard way of interpretation. You can see after we have passed this particular argument value Alan, and then later on we can retrieve that particular value, which should have been stored into the objects. And you can see get name actually tells you that somehow the Alan has been stored as a name attributes internally into the student objects over here. So that later, if you try to use Alan, which was initialized over here, Alan.getName is going to give you just the Alan value here that you actually stored previously, right? That's also something we spoke about before. So we can implement this right away. So let me simply go back to students over here. So that means we want to have an attribute to store the parameter over here. So let's say this. We can say private string and also name, all right? And over here, we want to make sure we store that. So this.name is assigned to name. Okay, let me go back to the tests over here. Now, if I simply run the JUnit test, even though we are still getting the red bar, however, let's see where we actually failed the assertion. If you double click on the failure trace over here, right? If you click on that, you will see that, let's see, we are failing over here. Oh, we haven't implemented get name. Sorry, I forgot. Let me just go do it again. Apparently, get name will fail because currently get name is still returning just null, right? We haven't done that yet. We only store the value into the attribute. We haven't defined how to return it. So return this.name over here. Okay, let's go back there. If I run the test again, you can see where we're failing is line number 20. If we go there, you can see, so that means this is the first point of failure over here. All the previous assertion actually have passed. So at least we get a get name to work, right? So that's something hopefully you're very familiar with already. All right, so now the get ID, and get ID. So this example here, I didn't put any textual description over there, but in your actual test, you will be explained about what this ID is really meant for. And I would say this description here will be very similar to your programming, your practice programming test number 4. So every student has a unique ID, okay? And the unique ID is simply a string value. And the unique ID consists of, let's say, 3 parts. Part number 1 is going to be their name, which they have been initialized into when the object was being created. So part number 1 for the unique ID will be their name. Part number 2 will be a dash. Part number 3 will be some unique integer over here. And we say that the integer, let's say in this case, the very first student object is going to have, for the third part, have the value 3. The second student, 5. The third student, 7, with an increment of 2, apparently, right? You can see 3 to 5, and then 5 to 7. So that'll be the rule. All right, so that will be the rule for the ID. So in your actual test, maybe the rule might be slightly different, but the principle will really be the same. Let me remind you something very quickly. You can see here, when we actually first create this object over here, we did not actually pass the ID as a argument, right, to be stored. So that means the ID somehow has to be managed internally, right? And also, I would encourage you to go back to your week number 10 lectures. So the motivating example for using static variable was we always pass an ID over here as a second argument for the constructor for the account. I think it's for the account in the lecture. But that's actually very error prone, and also you don't want to manage that manually. So that's why we want to use static variable to say whenever you actually create your objects over here, you don't really need to put that unique integer as part of the parameter list. Okay, that's something I also explained in the lecture, right? You want to review that as well. All right, so now how do we do this one here, right? Well, apparently we want to use a static variable because we want something that's global, right? Again, So this scenario will justify the use of a static variable because we want some global variable, global counter, starting from 3 and then increment by 2, 5, 7, 9, 11, and etc. automatically among the objects that we might create for a particular class. In this case, the student class. That's what we want to have, right? So we want it to be cumulative among objects. So that's why in this particular test, in order to make it work, we must have some static attributes. Okay, let's go back there. And then let me go back to the students over here. Okay, let me just start something with something, and then you can help me a bit. So we don't really want to get access to the counter directly, so this should be private. Let's say private static integer. Let's say I can say I, or I can say counter. Let me say I. Okay. Let's say this. Okay. Let's say this is what I start to type with. However, how do I make it work? I'd like to take some suggestion if you want to give a try before I tell you the solution. Anybody? I'll pause a bit over here. You can tell me what I should do. Do I need any more attributes, or do I need to do anything with this? What should I do with this particular static variable?
Sir?
Michael, go ahead.
I would suggest, because when I did the practice test, this worked, I would make another I'll make another attribute to store the static, like because you're eventually going to store the ID.
You will make another attributes. What type?
String.
Let me say private, static or non-static?
Non-static.
Okay.
Private string and
ID, maybe?
ID, yes.
Okay, very good. So now basically, Michael, very good. That's the same as what I'm thinking. So if we look at these two attributes over here, line number 5, we are declaring some global counter, which will be used as part of the student ID among individual objects. And line number 6 is a non-static attribute called ID, which means every object of type students is going to have have their own copy of this particular ID, right? So let me just say this. Each student object has its separate, its own copy of ID. And on the other hand, because this variable here is static, all students objects share the single copy of this particular I over here. All right, very good. So Michael, let me ask you this. So do you think, typically we said you should really initialize the static variable, right? So what value should we initialize I into?
Well, it depends on your setup, but you can just make it 3
yeah,
now.
Sure. You're right. So I would say typically you really should actually give some explicit initial value to the static variable. I would say for this one here, since the ID here is going to start with 3, so why don't we just start with 3, right? You can start with 0 and then try to increment it later. That's fine, right? I'll just give you one example, one possible solution. Let's say initialize to be 3, okay? And then, Michael, what else? Maybe you can help us out. I'm pretty sure you know how to do it, so I can let you help your fellow students. What will be the next step?
Then we can, maybe the way I did it is not as correct, but I just went straight to the get ID method.
Oh, you just went to the get ID method over here, right?
Yeah.
Interesting. I see. So just tell me what you did. There might be one possible solution. I can also give mine so people can take a look at too. So what would you do in the get ID? Return?
So here I would, because in the practice test, it made a new object every time in each test. Okay, well that's not really because you're not calling the method again on Alan on Alan twice, so it doesn't matter here. But what I basically did was I made a string that the get ID returns, and I just concatenated the name, and in this case you add a dash in between, and then the ID, and then you increment I by 3.
I kind of see your point. Let me see this if that's accurate according to what you just said. Let's say how about string s over here? Will be basically this name, the name concatenated with the dash plus, and then plus and also the static variable over here, I, right? The current value. So let's say I over here. You can either say I or you can say students.I. I think this will be better to actually just remind you it's actually a static variable. And then Michael said you will want to increment it, right?
Yes.
Interesting.
By 3, right?
By 3, you're right, absolutely right. Very good. By 2, actually, in this case.
Okay, yes.
3 to 5, 5 to 7. Yes, very good. However, it's interesting. I would say this will be okay for passing this test over here. I agree. Because it seems like we're only calling the get ID on this particular Alan only once. But realistically, you may inquire about Alan's ID for as many times as you like. And they should always give you the same ID. Right? So Michael, do you see what I mean?
Yeah, so
now let me put something here. Yeah, let me just say this.
Yes.
And then, first of all, let me say before I do this one here, before I do this, I will try Michael's solution over here. And green bar, fantastic. Okay, as far as the given test is concerned, it's perfect. However, let's say this. We want to introduce, maybe that's something I can also include in the actual test. So here we say invoking get ID on the same context objects should return the same ID. So which means if I try to invoke Alan get ID on Alan object again, invoking that twice should really give you the same ID for the first time and the second time. It should be. However, would it be the case for Michael's solution?
It's not.
It's not. Okay, Michael, you know what? It's really interesting. I actually haven't thought it that way. That's nice. So Michael, can you explain why this will fail?
Because if you call if you invoke the accessor method get ID on the same object twice, because the static variable accumulates with across the objects, then Alan would not just be 3, it would be in this case 9.
Okay, very good. Let me try to formulate a little bit over here. Okay. In this, if you don't mind, I'll say wrong version of solution. Wrong version of solution. Static counter is incremented every time the get ID method is invoked, even with the same context objects. Right? That's exactly what's happening over here, because you can see we're trying to invoke get ID once and twice with the same ID. So that means the first time you actually invoke get ID with Alan, you get something. But the second time you do it, you will increment whatever value it is for ID, I mean the static counter, by another one, right? So that means the what you would the value over here will be actually 9. So that'll be Alan 9, right? So that will be the value that's wrong. Okay. All right, so basically that's wrong. It's good to know about this wrong version over here. It's good, definitely good. So now how do we fix it? At least we know we shouldn't actually increment the static counter I over here by just every time the get ID is called by the same context objects. You might be thinking, is there a way to check to see whether the current context object that's invoked, invoking this get ID method, is the same as some previous one? I would say that one logically makes sense, but it's making things way too difficult. You don't want to check about the context objects. I would simply say you're just updating the static counter in the wrong place, just the wrong place. You want to make sure the static counter is updated for each object for one and only time, just once. Any suggestion?
So that the static should only be invoked in the construction mode.
Yeah, in the constructor, exactly, because every object can only be created once. In that case, you want to make sure in that one and only call to the constructor for that particular context object, you do whatever that's necessary to update the static counter. Yeah. All right. So guys, I think I'll leave this guy over here for you over here. I'll leave that static counter here. So that's the wrong version. Okay, just be careful. So what we can do is we can say what we should do is I would suggest let me do this. Okay. Let me say this. Let me just put this line because somehow they're related. I'll give you one example solution. You can play with others as well. Okay. So this is the solution here. I would say I comment this out over here like that. So we don't really do anything. So here it can be as easy as this.id. That's all I should do. Okay. I just want to use the ID. And Michael, did you realize that in your original solution, you're not even using the ID string actually, right?
Yeah.
So, yeah, okay, anyway. So that's something I just realized.
All right.
So what we should do is, why don't we try to set the string ID attributes once and for all in the constructor? So why don't we say this? We can do something very similar. We can say this.id is assigned to this.name plus the middle dash plus the current value for the static counter. So students.I. So for the very first object to be created, when we call the constructor, we're going to get the value 3, which is right? Of course, if you somehow initialize the value to be 0, in that case, you will have to make sure you increment it by 3, right? It's kind of a different solution you can play with. All right. After this, we can now, so now you will be okay to actually increment. So this dot, sorry, not this dot I, sorry, students dot I plus plus. And let me make a comment over here. This updates, this updated value will never be used by the context objects. So what it meant was, for example, let's say this. When I call this the first time, Alan is the context objects. And for this very first call to the constructor, we will actually increment student.I from 3 to 5. However, the context object Alan will never actually be able to use that particular value for the ID, right? Well, they can still get access to the variable, but since the way we set it up, the ID over here is always going to be just 3, not really 5. Okay, so that's something to keep in mind. All right, let's now try to go back here, and then let's now run a test. Am I doing something wrong over there? Oh, should be 2. Yeah, Michael reminded me before, but I always forget. All right. Okay, green bar, right? Let me make it even better. So it will be the same for the other object as well, right? So it should be always mark 5 and times 7, right? So I'm sure this is going to be fine. All right. So guys, so that's about, I think this kind of nicely complement what we complete our discussion for static variables back in the lecture. So in the lecture, I only try to describe things in the paper, on the paper. So now you see exactly how it works from scratch, right? All right, any question about using static variable for global counter purpose? Any question about this?
Professor?
Michael?
Is it wrong to use the static variable in the getID method?
You mean to use over here?
Yeah, because like I understand like it's a bit more it's more proper to use it in the constructor.
Yeah, I think the updates. I think this part of this line here, I think it must be done in the constructor because you want to make sure only when you create a new object will you actually update will you actually increment the value for the global counter. This line for sure. However, this line over here, you know what? Michael, here's the issue. Okay. Are you suggesting something like this? Dash plus student I. Are you suggesting something like this and then return S?
And not really. Like
what are you suggesting?
What I basically did was I moved this.id, that method, and student.I plus equals 2 to the ID method.
No, actually no, because if you try to do student.I plus equal 2 inside the get ID, the problem is every time when you try to invoke this method, even with a context object that has been invoked before, you will still actually increment the ID.
So then what I then did to get around that was I put it inside an if condition where it checks if this.name equals null.
This.name equals null. You know, Michael, intuitively, I don't think that's going to work. Did you actually try that with?
Yes.
You did?
Yeah, I completed my test using that method, yes.
I mean, even with duplicated call to the get ID?
I think it worked, yes.
Why don't you, Michael, if you don't mind, show it to me at some point, maybe offline. If that works, we can speak about it maybe to everybody, maybe on Monday.
Okay.
Yeah, because I'm not exactly sure how you did it. So that could potentially confuse if I just talk about it. Maybe just speak to me maybe offline about your solution. Okay.
I'm just wondering if it's improper because...
No, it's not really improper. I think the reason that I spoke about the most intuitive solution, let me just go back here. Since we actually want to, from the user's point of view, we want to make sure every time after you have created one object of that particular class, you want to increment the internal global counter. That's the main key. And then, so that can make sure every time you actually try to invoke the get ID on a particular context object, no matter how many times you invoke this method on the same context objects, it will always give you the same value, like Allen-3 and also Allen-3. Another way you can do, for example, is like this. Another way, you can potentially, let's say this. I can say private integer, let's say local I. Let's say that, right? If I do that, let me comment this out. Okay. What I can do is I can say this local I is assigned to the current value of I. So this will make sure the local I catches the value that's really only for this particular student I've just created, right? And then later, rather than saying this.id, what I can do is I can simply say this.name plus the dash plus, rather than student.I, I can say this.local I. So this may also work. Yeah. So that's just another way to do it. So which way you would like to do it is completely up to you. But I think the principle that you have to understand is the difference between static versus non-static variables. All right. Guys, any more questions? I have no further items on my agenda. So if you got any questions you want to ask, feel free. But we still got Monday's Q&A if you want to come back. That's also fine. Okay. Yeah, we got the basically final 2 weeks. I understand that everybody's busy. But we're just gonna finish the stuff, right? In the final 2 weeks. And then we also have to worry about your exam. But I'll get in touch about the detail for the exam. For now, you don't need to worry. Okay. Michael, you're welcome.
What about the final test? Like any agenda or format?
You mean the final programming test or final exam?
Final exam or something like that.
Yeah, you mean during the exam period, right? The final exam.
Yes.
Yeah. So the time has been fixed already by the register office. It's April 20th. I believe it's 9 a.m. for 3 hours. Me and the instructor from section O, we will discuss exactly how to run the exam. it will definitely be within those 3 hours. May not be a full 3 hours exam. It might be only 2 hours, but we get to finalize, and we'll let you know as soon as we can. So you get enough time to get prepared. But I think that you wouldn't be a wrong bet if you try to if you try starting to review all the lecture materials and tutorials for the exam. It's going to be a written test. It's not a programming test.
Okay. Okay.
All right. All right, guys. Anything else you want to ask me? Selvets, are you here? Okay, so maybe I guess she's not there. All right, guys. So I think that's about it. Yep. So I'll make the video available to everybody, so you can review parts of it if you got any doubts. All right. Have a good weekend, and then I'll see you on Monday. All right. Take care. Bye-bye.